Hello guys, in today's video we will see how to calculate the effective mass of an electron. Okay, so first point is that first of all we are going to write the velocity of electron in one dimensional potential. So that is written by d omega by dk. Okay, this is especially for which is equal to the group of velocity of waves representing the electrons. Now we know that E is equal to h cross omega. How are we coming to this? Now we know E is equal to h mu, this is frequency. Now what I'm doing, dividing by 2 pi and multiplying it by 2 pi. So that is how we are getting this. H by 2 pi is nothing but h cross, and omega is equal to 2 pi f. So now if I differentiate it with respect to k, this is a constant term, it will be as it is, and d omega by dk. So I'm just writing it in terms of d omega by dk. I'm getting 1 by h cross into dE by dk. Okay, this is our first equation, this is our second equation. Now you can see RHS of this first term is equal to the LHS of this term, so we can compare both the terms. So we can write V is equal to 1 by h cross into dE by dk. This is our third equation. Okay, so now this was the first part of this derivation. Now coming to the second part of the derivation, we know that power is equal to force into velocity, but we know that power is equal to dE by dt, that is change of energy with respect to time, and the force on that electron is minus of EE, because that is the force on an electron. So we can write that dE by dt is nothing but minus EE times V. Let us mark it as fourth equation. Now if we compare these two equations, what we can write, dE by dt is equal to minus of EE, and instead of V I am substituting this third equation, that becomes 1 by h cross into dE by dk, right? So now I can write dk by dt, this term will get cancelled, minus of EE into 1 by h cross. This is our fifth equation. So I hope of all the five equations currently are clear to you, whatever we wrote. Okay, now coming to the third part of this effective mass of an electron derivation. Now we know acceleration is nothing but rate of change of velocity. So from equation third, what we can do, d by dt of what, 1 by h cross into dE by dk. Right, we are just substituting the value of V right over here. So what we can write, A is equal to, this term is constant, 1 by h cross, this becomes d square E by dt dk. Okay, so now what I'm going to do is multiply and divide by dk. Now why am I doing this, let us see. 1 by h cross into d square E by dk square, so that we can simplify and simplify and write the term, and we have the value of dk by dt, isn't it? So I will substitute this right over here. A will be equal to 1 by h cross d square E by dk square, dk by dt is nothing but minus EE by h cross. So we can simplify and write minus EE by h cross square into d square E by dk square. Okay, so now I can substitute the value of A as F by m star, where m is the effective mass of the electron. Okay, this is equal to, now this minus of EE can be written as what, F, right, because force is equal to minus of EE. So F by, what was the term, F by h cross square into d square E by dk square. Okay, so we can simplify it again, and you are going to get 1 by m star is equal to 1 by h cross square into d square E by dk square, and you are getting the value of m star as h cross square by d square E by dk square. So this is the final equation for the effective mass of electron. If you want to take the screenshot of this derivation and just write as it is in the examination, and you're going to get full marks. Thank you so much, guys.